hello everyone. Now ready for the webinar today. Thank you for joining today's webinar. The title is The Bamboo Story. I'm Florence Chen, President of AIA Hong Kong. Last month, we had a webinar with Ed Mars-Rier of Architecture 2030, who gave us some great ideas of what architects can do to help fight against the global climate changes. Among the many ideas, one is really about careful selection of sustainable building materials, which we all should try to pay more attention to what we select and specify as an architect. To continue this discussion, today we are working with Bamboo International to offer you this webinar and bringing to you a group of young and energetic speakers today, plus a very experienced architects to share with us their work on bamboo, which is a highly renewable materials. The moderator of today is our member, Ms. Jackie Look. Jackie is an architect and a great advocate for sustainable living. She's an associate principal of KPF. And in addition to her professional endeavors, Jackie founded the furniture company, Project J, which focuses on using sustainable material through this reinvention ideas about living to design her furnitures. Her works has been exhibited in Copenhagen, in Stockholm, Victoria, and also most recently in the Milan Design Week 2022. And with that, I'm passing it to Jackie to introduce our speakers for today.
Thank you, Florence. So today our presentation will be divided into 4 parts. So first we have Alex, who is the Managing Director of Bamboo International. Alex was trained as an architect. He has more than 30 years of experience in real estate development, investment with highly successful career with Sun Hung Kai Properties, Portman Holdings, Prologis and Tishman. He has a passion for environmental sustainability and founded Bamboo International in 2018. And so many of our members have seen Bamboo International's product through our AIA tours, which include our M+ Museum, Shaw Auditorium, and me personally, I've seen the products in Tai Kwun as well. And so then we have 3 other speakers, very young speakers. We have Dr. Lian Dong, who is an environmental engineer, and he will look at or talk about bamboo from the environmental point of view and in terms of circular economy. And then we have Dr. Fan Rong and Mr. Andy Ong. So they are both mechanical engineer, and they will talk about bamboo from a scientist point of view, and also how they further the scientific research of bamboo and started a company, Super Bamboo. So let me pass the floor to Alex.
Hi, everybody. This is Alex Chui of Bamboo International. Appreciate the opportunity organized by AIA to talk about bamboo today. So I will first cover bamboo currently, how it's doing in building construction, and what I see the outlook for the future. Now, what is bamboo? Bamboo looks like trees, but it's not. It's grass. It's one of the fastest growing plants. It's harvest ready in 5 to 7 years. And Asia has the richest resources in bamboo. And in modern international bamboo trade terms, China is the biggest. It accounts for about 71% of the world total. Now, what are the benefits of bamboo? There are many benefits, but I think in the modern today's world, one of the most important benefit of bamboo is ecological benefit. Growing of bamboo doesn't require any intensive management and actually irrigation. Bamboo forests can release 35% more oxygen and absorb up to 5 times more carbon dioxide than trees. So naturally is a very important element in the global carbon sink and climate balance. And one thing that I have to point out is bamboo has a very strong and robust root system, and it will survive after harvest and will grow afterwards. So there's no risk of soil erosion or deforestation in bamboo harvest. Now, bamboo has been used in construction for a long time. Evidence suggests that bamboo construction first appeared in China in about 4,000 years ago. Bamboo has very good tensile strength in the long direction. It has a very unique characteristics. You can create very beautiful, unique architecture from natural bamboo pole, but certainly it also has its limitation. It's difficult to codify natural material. It limits its application in industrial application. And also the round shape of bamboo pole also would impose certain limitation on architectural design that we can explore with bamboo poles. In the past, I think in the past 3 decades, we start to have industrial products in bamboo, which we call the engineered bamboo. The manufacturing process is quite simple. Harvest the bamboo, cut it into individual bamboo slabs, treat for all the future use, and then we will form the bamboo into individual components. When we look at the bottom right corner of the slide, which is the basic components of all the engineering product that we'll see nowadays. Now, commonly there are 2 types of engineering bamboo, what we call the solid bamboo, basically a laminated product formed by individual slabs, glue placed together, and then the strand woven bamboo is crushed into bamboo fiber, and then we apply quite a lot of glue and then heat press together. Now, solid bamboo, when you look at it, is much greener, but in terms of strength, it is weaker than strand woven. But at the same time, it's more flexible. It can mold and bend into a lot of different shapes and profiles. So in building applications, solid bamboo is more popular, but strand woven bamboo, when applied for, say, as a floor or decking in high traffic situation, is very hard and very robust. If you compare engineering bamboo with wood, it's harder, it's stronger, and we try to create a special design features using either wood or bamboo. Engineering bamboo actually can lead to much less wastage, as actually we can mold and bend bamboo in a lot of different shapes. Now, I said about bamboo can be flexible and agile for architectural design. So what can it achieve? So seeing is believing. Now I'm going to share some of the projects that we have done in the past. Seeing is believing, right? So this is the short auditorium. I believe some of you guys have been to the auditorium in the building tour, AI building tour in June. Second one is the M+ Museum. We are doing all the mullions, ceilings, and walls. And then this is the Kowloon East Regional Police Headquarters in Kai Tak. One of the standout features in this project is the architectural fin in the ground floor lobby. It stands at 8.5 meter long without any visible joint in between. So it's a very great piece of work that I think you guys can look at in the future. And this is the Double Cove shopping center in Ma On Shan, Sha Tin. This is the only retail project in Hong Kong that has used bamboo in such extensive scale. Year completion is quite a long time ago. It's 2013. Now I will turn to some outdoor experience that we have in China. The Chinese government, they are actively promoting bamboo, and then actually they're more open in trying to apply bamboo in different sorts of applications, including structured bamboo. These 2 are not structured bamboo, but then later I can show you pictures of our structured bamboo experience in China. These are 2 bamboo trellis in the tourist park in Chengdu. And then this is a structural bamboo experiment that we did for the 2019 International Horticultural Exposition in Beijing. You can see the scale of the bamboo structure compared to the person just below the arch. That is, I think, about 4.5 meter clear height of this particular arch. This is another very interesting project in Nanjing. It's an ecological restoration of an abandoned quarry. Is a very interesting steel bamboo composite structure that we apply in here. And these are some other special elements that we have been exploring, designing with different architecture designers. I draw attention to the bottom right corner, the picture over there. It is, we're actually experimenting with a luxurious brand to see how we could apply bamboo in consumer products. So let's see, how far we can go with them. It's exciting. These are some of the OEM furniture that we're supplying. As I think you will see, the market of bamboo in Hong Kong actually is quite narrow. And currently most of the business, not just us, but for the global bamboo market is still the US and Europe. And these are all OEM exports to our retail customers in the US and in Europe. Hopefully we can have more of them in Hong Kong in the future. Now, about bamboo promotion, the global promotion of bamboo. INBA is an international intergovernmental agency formed under UN Charter to promote bamboo. Besides green, I have to point out that bamboo economy is actually a social initiative. Bamboo and rattan grows locally in some of the most backward communities in the tropical and subtropical regions. Since its founding in 1997, INBA has been promoting bamboo and rattan business in this region and has successfully created jobs for about 250,000 people. So it's an amazing job done by them. And it's the same case actually in China. Bamboo economy has been identified in China as one of the key initiatives to promote employment opportunities and income to local peasants. Beijing has set out a very ambitious goal. They would like to use to promote bamboo economy to alleviate up to or above 1 million people out from poverty. And where our factory is, the Jiangxi province, in this province alone, 150,000 jobs has been created in the past 10 or 15 years. So bamboo is what I see is a green and social initiative is an important initiative that I think we should all look at. And INBA is also working closely with ISO to try to develop new standard to enable the application of bamboo in a more bigger scale in different parts in the world. There's a major breakthrough this year on June 22nd, 2022. There's a new ISO standard release, which set out methodology to determine the physical and mechanical properties of engineering bamboo when application as a structural components. We hope that this will lead to a much wider application of bamboo in the market. Now, I think it's more a matter of individual countries to incorporate this new ISO standard into their local regulations. Now, what I see the outlook, sorry, excuse me. The outlook for bamboo economy, I think there are two key drivers. One is regulation. The right-hand side, it is the Brooks Common Phase 1 in the University of British Columbia. It's an 18-story tall timber building. It's a pure laminated timber building on top of a concrete base. Now, if you look at the physical strength between bamboo and wood, what we can achieve with laminated wood, actually we can achieve the same with laminated bamboo. The reason why we don't have bamboo buildings like this is purely regulatory. Now, if you look at the ecological benefit of this building, based on the information released by the architects, this building alone, the saving in greenhouse gas is equivalent to removing 511 cars off the road in 1 year. So it's a pretty high, significant impact on the environment. And INBA and ISO, they're championing, try to promote structural bamboo. I think one of the reasons is if we can create more buildings in bamboo, it can lead to a more significant carbon sink within all these buildings. So I think that's the end for my part. First, I will pass it to Dr. Dong.
Thank you, Alex. Before Dr. Dong start, let me have a brief introduction about him. So Dr. Dong is an environmental engineer, currently assistant professor at City University of Hong Kong. His interest is in life cycle assessments, carbon footprints, circular economy, and its application for urban sustainability. And his research had been published widely with over 120 publications. So let me pass that to Dr. Dong.
Okay, thanks for the introduction from Jackie, and it's my pleasure to join the great event for today. I will share my PowerPoint now, and okay, so I think you can see my PowerPoint and my voice is clear enough, right? Okay, so thank you so much, and I will discuss something about how we can assess the environmental impacts for the bamboo products. So I will mainly to introduce how we can apply the approach like life cycle assessment to calculate on the whole life carbon emission for the embodied carbon emission in the bamboo to highlight its contribution for the future carbon mitigation in our building sectors. So here I want to highlight the two big pictures from the energy and the material side. So this one is the total picture to show the Hong Kong's condition on the carbon emission. So here we can see the total carbon footprint in Hong Kong, and we can see the building sector actually account for most of the carbon emission. So it is significant for the building sector to think about how we can promote some better way to save energy and to reduce the embodied carbon emission to realize the Hong Kong's target on the carbon neutrality in the near future. And also, meanwhile, we also know the building sector actually is also the main consumer for the raw materials and the critical materials, and also some the rare earth materials. For example, this figure to show the data in the European Union, we can see the building sectors. Our building actually have the bulky amount on the materials like the cement and the aggregates, and we know the steel and also something the flex glasses. And we also to know to produce these kind of the materials, we also have to consume a lot of energy because the process on the producing the materials is also very high energy intensive. So how we can reduce carbon emission from the material side is also maybe some new attention we should pay in the near future to reduce the total carbon emission embodied in the building sector. So also some the hotspot with the academia recently. So based on these two big data and the picture, we can see there's the typical life cycle on the for promoting the building measurement. Okay, so we can see that we have the different life cycles to make the buildings and the infrastructure. For example, we have the extraction for the raw materials and mining, we know is very polluted, and also the transportation and to produce the raw materials for the building sectors. And also we also have the in-use stage, like we manage the building energy efficiency, and we also have a demolition stage and how we can manage waste recycling for the building materials. So if we put the carbon emission into the different life cycle stages, we can see maybe there's much higher potential we can reduce the carbon emission from the. Now we pay much attention on the in-use stage. So it's also a time to pay more attention to the raw materials, how we can reduce the carbon emission from by using some more renewable materials is a very important way to reduce the total emission on the building sectors. So here we can see the benefit on the renewable energy and also the renewable materials. Here is a case study we have done in the Yangtze River Delta in China. So we accounted the building material consumption for the 36 cities in Yangtze River Delta, like Shanghai, Nanjing, and Hangzhou. So we can see, apart from the bulky material amount consumed in all the buildings in the Yangtze River Delta, there's also a significant number to highlight on the embodied carbon emission. For example, the carbon emission and the consumption emission to produce the cement, to produce the steel and the sand and the gravel. So here we can see, if we can pay much more attention on the material side of the life cycles on the building sectors, they can offer the second round space for the carbon emission to realize on the carbon neutral scenarios in the near future, for example, for Hong Kong and also for the global. So based on this idea, actually, we can think about what kind of the material will be more benefit to our environment and can help to reduce carbon emissions. So here we have the ideas of to utilize the more renewable resources because they can generate the carbon benefit from the embodied carbon side, or we can see they can reduce the life cycle carbon emission for the building sector. So if we can apply the more renewable materials, not like the cement or steel, we can also to contribute more to the carbon mitigation in the building sector. This is the big picture and the ideas for this project. So based on this idea, actually we assess the life cycle carbon emission, or also so-called the embodied carbon emission for the engineered bamboo products. So here is the very basic process to show the bamboo. We know that is the final engineered bamboo products, and to produce this one, there's many processes will be integrated into the whole life cycles. So we have the bamboo harvesting and transportation to the plant, to the future processing, like we have the seeding of the raw materials, and we have the splitting of the bamboo clumps, and we also have the rough shaving and some different processes, and afterwards, for example, maybe the fungal treatment and the driving and the moisture content control, and also the precise shaving and the color sorting and the gluing, and also something like the assembly, and also finally they will become the final product and will be shipmented to Hong Kong. We know transportation will also consume some energy and material. So if we can account for the total carbon emission for each process, we can offer some picture to show how much embodied carbon emission will be for the bamboo. This is the bigger picture of the process on the bamboo manufacturing. So we also applied life cycle thinking and assessment to accounting for the carbon emission embodied in the bamboo. So it's a typical and standard the life cycle assessment approach, and we will account for from the plantation to the manufacturing to the products. And also we will also to think about some end of use scenarios to further account the total life cycle carbon emission, and we transform the data into the per unit value data, like the kilogram CO2 emission per kilogram the bamboo products. That is the methodology we applied to account for the whole life carbon emission. And here we can see the energy consumption and the CO2 emission for each process. And our final calculation result will be from the bamboo harvesting to the end of for example, the transportation to Hong Kong, the total life cycle carbon emission for the unit bamboo will be about 0.8 kilogram CO2 emission per kilogram the final products. But it is only from the cradle to gate. We also to know bamboo in nature, it is the plant. So plant also, due to the photosynthesis effect, it can absorb carbon emission in the process of growth. So bamboo also have the benefit on the carbon sequestration. We will also to think about this kind of the benefit and the results. So this figure to highlight the process-based carbon emission for the bamboo products, and we can see some process can be potential to be future improved. For example, the much higher emission will come from we can imagine the transportation, for example, from the mainland to Hong Kong due to the shipment. And also some higher carbon emission is observed and accounted for the fungal treatment, and also like something like the process shaving and also the hot press. They will use the steam and the very high internal energy consumption for this process. So if we can use the data, we can also to enlighten how we can further to improve the different processes to try to reduce the process-based carbon emission to optimize the carbon emission for the bamboo product. This is also some figure we can see the numbers on this figure. This is the details carbon emission for each process on the bamboo. And also, as I mentioned about, bamboo is the biomass and also is the plant, so it has the benefit on the carbon sequestration. So if we think about on the carbon absorbed in the process of the growth of the bamboo, we can further to reduce the total life cycle carbon emissions. For example, the data from the paper shows the bamboo growth in the mainland China, like Fujian and Jiangsu province, the carbon sequestration benefit will be about minus 0.607 kilogram per kilogram bamboo. And also the number will also be changed due to the end of life. For example, I applied the scenarios from European Union. 90% of the bamboo waste if come from the power generation and only 10% will be landfilled. The benefit on the end of life will also to further to reduce the carbon emission by 0.7 kilograms. So that means we can also to reduce the carbon emission by burning the bamboo to reduce fossil fuel consumption for the power generation. So if we plus the benefit on the carbon sequestration and also the benefit on the power generation from the bamboo waste, the total life cycle carbon emission for bamboo will be further to reduce into, we can see the number is minus about 0.493 kilogram CO2 emission. That means bamboo is not only the carbon neutral, but also actually tend to the carbon minor. So if we can apply the more bamboo into our buildings due to the nature on the carbon minors, we can contribute to the net zero buildings in the near future. So that is something we can highlight based on the assessment on the life cycle carbon emission in the bamboo. And we further compare the bamboo carbon emission with other materials in the buildings. For example, the number we can see here actually still is very high and it's intensive, and of course the high number on the carbon emission about 2.38 kilogram CO2 emission per steel. And also if we look into some other material, for example, can be potential to be substituted by bamboo, we can see the wood is about 0.2 kilogram CO2 emission per kilogram of wood. So it's very close to bamboo without recycling. So actually here we can see, of course, the different material have a different function. We can't use bamboo for all the purpose, but if we can think about and to utilize our inspiration, how we can improve the design, interiors or outside design on the buildings, maybe in the future there should be some more potential to reduce the whole life carbon emission for our buildings by applying the bamboo to some replace, for example, some furniture or some decoration or some floor, and we can think about. So that is the basic the data we can see, and also we can use the data to support on the future policy making to expand our usage and application for the bamboo-based products. Okay, so here actually based on the data, we have some general conclusions. And we can see the industrial bamboo has a significant potential to reduce the current whole life carbon emission for our buildings because in nature it is a renewable materials. That means the benefit on the mitigation for whole life and life cycle carbon emission. And also, we also know in the real practice of the green building, some current non-renewable materials like the plastics and the wood and the concrete, right? Therefore, could be substituted by the bamboo based on, of course, should be based on the feasibility. So we need to open the imagination, and we need the inspiration from the designers and architectures. And also, some specific process of the bamboo also highlights some relatively higher carbon emission. For example, the transportation and the hot press and the fungus treatment. So we can think about some future the potential improvement. For example, how we can utilize the more renewable energy and how we can promote on the hydrogen for the shipment, and how we can try to make the heat recovery on the plant, and also, for example, how we can utilize and the more efficient steam utilization on the plant. And we also think about some future concerns. We started on day to show basically the CO2 emission. So in the future, actually, also based on the life cycle assessment, we also think about to assess other impacts and the health impacts, for example, air pollution. if we can reduce fossil fuel, we can also to reduce air pollutant. This is very important. And also, how about water pollutant and the risk on the ecological systems, and also the impacts on the human health, for example, the life cycle, the life expectancy, and so on. And also, we also tend to make the detailed scenarios assessment to explore how the future to improve with current technologies in the engineered bamboo. For example, how we can apply the more clean fuels, and how about potential to apply the heat recovery, and how we can apply some low impact glue in the process to reduce other impacts for our environment. And finally, I think the practical case study will be very important to realize our ideas in the real world. So we intend to utilize the unit value for the bamboo to evaluate how the whole building will be able to reduce the carbon emission if they can use the bamboo in some proper place, for example, the furniture and decoration. So it also the next plan to show the real case to highlight how we can really to practice the bamboo ideas in the real world to support on the carbon mitigation and the neutrality scenarios in Hong Kong in the near future. Okay, this is my presentation, and thank you so much for the questions and the comments. Thanks so much. Yeah.
Thank you, Dr. Dong. I guess we learned that bamboo have very low or even negative carbon emission. I guess I really need to cross out linoleum, as I can see the carbon emission of linoleum is super high. I need to cross it out from my material list. And so next we have Dr. Fan Rong. She will talk more about the scientific research on bamboo and potentially even reducing the carbon footprint of bamboo even more through her study and scientific research. Dr. Rong?
Dr. Rong, please unmute yourself.
Can you hear me now?
Yes.
Hello? Okay, good, thank you. Yeah, thank you, Jackie, for the introduction. It's my great pleasure to introduce some of the bamboo science topic. Actually, our team, supervised by Professor Lu Yang, has been studying bamboo, especially in the in-situ mechanics and in-situ mechanics characterization of bamboo for more than 8 years. And now we are going to share some of our research in terms of the mechanical characterizations. And the following part that I want to share is that the super bamboo that we more focused on recently. Okay, so from Dr. Dong's introduction, we already know that bamboo could offer the significant reduction of carbon emission. And one more thing that I want to mention, but actually this one has been mentioned by Alex at the beginning, is that bamboo is actually one of the fast growing materials and one of the highest yielding nature cellular materials. It can reach its maturity within months and ultimate mechanical properties within few years. So when you plant a bamboo tree and also plant palm trees together and then wait for 30 years, you can see that you can produce roughly 300 pounds of pine trees, but you can have 5,000 pounds of bamboos, which means you will have more than 15 times the amount of building materials if you use bamboo. So bamboo has a very good potentials. Other than that, we also know that bamboo has a very good mechanical performance. Sometimes we will compare the bamboo's mechanical performance with some other formula construction materials, such as the concrete, the steel, and the wood. We can find the specific strength, which means the strength divided by the density. Bamboo is much higher compared to the other construction materials. And this is a specific strength, and this is specific stiffness. But when we compare it, when we do the bending test of these structures, compared to this structure, we can see that for the bamboo laminated ones, it has a higher mechanical strength, but for the bending modules, which means it is lower than some other materials. And in addition, all of this one are the nature cellular materials. But compared to the metals, we found the metal has a super high fracture modulus and super high fracture strength compared to our nature materials, which is not compatible. So why does it has such a phenomenon? Why does it has such a mechanical properties in terms of the things that we're showing here? Why? To answer that question, especially for material scientists, we usually will find the answers through the microstructures. When we talk about the microstructures or check about the whole structures of the bamboo, the first one is the regular bamboo structures that you already know that. It contains the hollow comb and also the solid node in here. But when we cut it off and then look at the cross-section areas, we can find it is not uniform anymore. It contains some, we could say it's a monkey face because it contains some dark part and also contains some white part. And when we zoom in again to the microstructure levels, to the until the nanostructure level, we can find each level, it contains some different structures inside, such as when we go to nanostructures, it is also contains thousands of microfibrils inside. So which means the total structure is the hierarchical structures of bamboo. In our today's topic, we will not include the nano part in here. We will more focus on the microstructure level, because for the microstructures, sometimes we can see it just from our eyes. We don't need to use any other tools to see this one. And we also draw a schematic pictures here, which means shows the typical structures, microstructures inside of the bamboo. And this page will give you more information of it. Okay, so for the bamboo, it usually contains the hierarchical structure like this way. And we also show two different directions. This is a transverse direction, and this is a longitudinal directions. It contains, we can see here is a scale by it's around 1 millimeters, which is we can see by our eyes in this area. And here it's around 400 microns until here is 20 microns. And from the large image to the smaller image, we can see that it contains different microstructure inside. We take this one as an example. So the bamboo contains some vessels here. So vessels is to transport the water and the nutrient, whereas they are all surrounded by the fibers. And in terms of the volume fraction, the fibers and the cellular parenchyma cells, like this one, this is the cellular parenchyma cells, and they are forming the majority of the bamboo cones. So these two parts, the bamboo cones contains the bamboo fibers and the parenchyma cells that will contribute more in terms of the mechanical performance. So we know that we can take a muscle bamboo. This is the most popular bamboo as an example. We can see that it contains around 57% of parenchyma cells, and also it contains 37% of the bamboo fibers in here. And once we know the microstructures of it, we will do some mechanical testing to test the mechanical behavior of it. Today, I will show 3 typical examples of the mechanical testing. The first one is the tensile and compression. We will just pick up the bamboo from the bamboo cones along the transverse directions, and then we will do the tensile test and do the compression test. And today, I will show some microstructures of it. Okay. Once the initial crack was reached the critical conditions for future crack growth, it will propagate along the parenchyma cells boundaries. We can see here, this is the parenchyma cell. It will usually along crack along the boundaries until it reaches to the fibers. But we can see it is also will crack through the initial surface of the bamboo fiber like here, and until it reaches to the vessels, because vessel is more like a hollow. So which means the total materials in here will be stocked and then find another way to have another crack. So the crack is important because sometimes we know that, especially for the construction, crack is not good. So we want to prevent the crack, especially if, just like if we have a glass, we know that glass is very brittle. If you have a very small crack, then the glass will be fragile. But for the bamboos, because it has so many interlocks, so the microstructure bamboo will prevent the crack propagation, will give you more toughness. And this is a picture to show the fracture surface of the tensile bamboo. We can see that the bamboo fibers was pulled out. This is the most prominent feature in the tensile fracture surface, which could be simply created to exhibit crack growth along the fibrous interfacial areas in the both radiational directions and the longitudinal directions. Other than that, we also did some bending test of it, because we know that fibers and also the parenchyma cells have a very important role in the mechanical performance. So we choose different samples, contains different part of parenchyma cells, the white one, and the fibers, the black ones, and do some mechanical testing and to check about how does it will affect the total mechanical behavior. So when we compare the model A, which means the more fibers will on the top area, and model B will be less fibers on the top area. And then we will do the 3-point bending test. The bottom part is fixed, and the loading will go through the top part in the middle of our sample. This is the typical mechanical testing process for any materials. So the model B is the test loading on the lower fiber. And compared to the model A, this is the stress strain curve. The stress is related to the load, and the strain is related to the displacement. We can see that the stress strain curve in the first stage, it is not linear. It's a nonlinear deformations here, especially before the fracture point. This is associated with the squeezing of the parenchyma cells, because previously we already know the parenchyma cells is more like a capsule shape. So for this one, because this area contains more space, so it will give more space for the compression. And compared to the model A, it will have not this phenomenon. And another thing is that it will have more serrations in here. This is also because that there have more denominations across in model B. And we did the microstructure check of the total structure again. So this is model A, and this is model B. From the model A, we can find that it will have the fiber bridges in this area from the large picture and also the smaller picture. We can also show them have the same phenomenon. And but for the model B, we can say that the fracture mode is more like the fibers pull out. It's named as the denominations. But both of them on the top side will show some squeezing of the parenchyma cells, so which is quite important for such a material that will give you more fracture behavior, more fracture strength, so which means it can deform more. So that is the typical mechanism or typical fracture mechanism of the nature bamboo. So other than that, we already know that the bamboo fibers and also the bamboo parenchyma cells, both of them are very important. But how does it will affect the total structures, or how can we get them and then to test it? So we find another ways to just isolate all of the parenchyma cells and fibers. There are two different magnifications. This one, the scale bar in here is around 100 microns. It's more like a length of your skin, more like the dimension of your hair. And also this one is a fibers. We can say that the fiber is more like a solid, but for the parenchyma cells, it's more like a capsule shape. Okay, so which means the capsule shape will give you larger space for compression, but the fibers will provide more strength. And some of the researchers also did some research about the tensile strength of these fibers. They also found that the maximum tensile strength of these fibers can reach to around 2.2 megapascal, which is quite high. But because compare our known tensile strength of bamboo, it's around 100 megapascal. So which means they have a larger space that we can improve for the nature bamboo. Other than that, I want to show the current bamboo materials. Actually, this one, Alex already showed some results. Show this part. I will just skip it. But my point is that the current state is that the total materials will have a lot of some of the toxic adhesive, and also the materials inside will have some initial cracks, so which is not good for the mechanical properties. And also that is why when we check about the compression and also the tensile strength of the existed bamboo product, it is not good. So our process is that we will use very simple two-time process to get the super bamboo project, to get the super bamboo. The first part is that we'll do the chemical treatment to remove the lignin and the hemicellulose inside, and then to make sure that the bamboo fibers and the parenchyma cells that were introduced today can be easily moved. So which means all of them can be fully compressed. That is the most important part we need to do. And another thing that we'll just use the bamboo material itself to glue them together, to glue it together, which means we didn't use any additional glue, especially some toxic glue, to our super bamboo samples. So this is show you the example of the microstructure. We can see that this one contains a lot of hollow, a lot of space, but this one, it is fully densified, which means that is why this material can give you more than 3 times stronger than the nature bamboo. And also this is 100 grain materials. And actually this is 2 other researchers. I will just skip it because my time is up. And yeah, I think that is all I want to share today. Thank you for your listening.
Thank you, Dr. Rong. Extremely vigorous research on bamboo down to its microscopic level. And you actually reminded us that bamboo, although is a very sustainable material, if we can eliminate glue, would be a breakthrough and make it even more sustainable. And so I understand you and Mr. Ong founded a startup, Super Bamboo. So basically bringing the research out of the lab into application level, and so that for us architects can even maybe one day see this product in the market. So next we have Mr. Ong. He's one of the co-founder of startup Super Bamboo, also a mechanical engineer, and so one of the achievements was last year. You started a startup Super Bamboo and raised over 2 million Hong Kong dollar to further the research on bamboo material. So I will pass the floor to Mr. Ong.
Okay, thanks Jackie again for your introduction. Yeah, hi everyone, I'm Andy. It's my pleasure to be here as the last speaker for the last section of this webinar. After my part, I will pass the mic back to Alex for a quick recap and followed by a Q&A session. But now, what I would like to share in my short time is really how there's an opportunity to add a strong business case for bamboo, and how there's a strong opportunity to add something special towards it. And hopefully by the end of this, we can convince everyone here to join us to take part in this opportunity as well. Now to start, earlier Alex has showed everyone some pictures of some wonderful projects that has been made out of bamboo. But let's take a step back and glance at the global market size of the bamboo industry. So in 2021, the global market value of bamboo stood at around 58 billion US dollars. And it is forecasted to reach around 83 billion US dollars by 2028. Now, of course, besides engineered bamboo, this number covers other types of bamboo products as well. But the takeaway is that there's already a sizable industry for bamboo, and we expect it to grow even faster following the exponentially increasing investment that has been put into the carbon reduction solutions globally. So next, the question for us was, how do we take part and contribute to this promising prospect? And our answer can be summarized by this diagram. We believe there's a special opportunity where material research scientists, the startup ecosystem direction, and the industry can come together to create a positive feedback loop. And this win-win-win solution hopefully can allow us to not only take part, but also to change the game in the bamboo industry. First step is research. It is a background where both Irfan and I come from. We work in the nanomechanics and mechatronics lab in CTU, which is directed by Professor Lu Yang, which you can see here in this picture. So just a bit of history. Professor Lu Yang got interested in bamboo when he was a postdoc back in MIT around 10 years ago. And in research, our modus operandi is always to study and understand the underlying mechanisms. And then with that, we try to improve or invent something new. And that is exactly what happened here. Dr. Fan has extensively showed you guys how we try to study the microstructure of bamboo, which allow us to really do something different where, usually in the past, the manufacturing of bamboo is really done in the high scale level where people do trial and error in the manufacturing state. But for us, we try to, rethink of how do we improve the material by having more of a bottom-up philosophy from first understanding how the material works itself, and which eventually led to super bamboo being invented. And as what Dr. Fan said, super bamboo is a new novel material that is patented, and also basically it's a bamboo material that is over 3 times stronger than natural bamboo, and it's the first bamboo material that we know that exists without having any kind of polymer, resin based, or at least formaldehyde based glue. So we think it is a big breakthrough. And with that successful proof of concept, the next step is to commercialize technology and try to bring it to really useful real life applications into the market. And in Hong Kong, we have amazing support, which makes it possible to spin off research into a company. And for us, we first gain support and funding from the university level, where they support startups. And then we also get support from startup incubators by the Hong Kong government, such as Hong Kong Science Park. And once our model has matured more, we'll engage with Hong Kong venture capital, which currently is very, very interested in investing their money and capital into projects where we can reduce carbon for the world. And in Hong Kong, we're also very fortunate where, besides the main path of funding, a lot of more other organizations, whether it is in terms of research funding matching, or also startup councils that support us in terms of giving advices on how to scale up, and other kind of organizations that help us solve problems like in terms of media coverage, how do we solve the administrative problems, and etc. So the support is really there. And in the just span of 1 year, we were very fortunate to gain some notable awards for our technology, including the Gold Award in the International Inventions Geneva last year, and also the Merit Award in the Mechanical Innovation Award just a few months ago. And we're also incredibly excited to realize that media and the public has shown a lot of interest in us as well. And this is so important because at the end of the day, demand of the consumers is really what matters. Which is a nice segue for me to my last slide. In recent years, I think the interest of using bamboo is increasing in a palpable way. And developers and construction companies know that it is a necessity to drive down their carbon footprint. And so we have had many of them approaching us and wanting to know more about bamboo, our technologies, and whether there are collaboration opportunities. So how do we take this to the next step? We believe the way to do that is first we need to understand each other even more. Architects, we believe, will have an integral role in moving forward in connecting developers, construction, and even our technologies on how we can really implement this into real buildings. So a webinar like this is a good first step to connect and allow opportunity to know more about the material itself. And I believe as we continue our conversation and know more, I think even more great things are about to come. So that is the part of the end of my part, and I'll pass the mic to Alex. Thank you very much for listening.
Thank you, Andy. Definitely a good first step today with the webinar for us to actually learn about the material. We have seen the material and the product of bamboo being used in architecture. And so I guess we can open, we can answer some questions from the audience. And before that, maybe I can start first with my question. So my first question is for Alex. And so from your presentation, I learned that your company, Bamboo International, is not only just a sustainable initiative, it's also a social economical driver to create jobs and help end poverty in China potentially. So today you brought together scientists, manufacturers, and even architects. I can see your true passion for bamboo. And so what inspired you to start Bamboo International? And did you see a lack of locally sustainable material in the market? And in terms of future of bamboo, you see government policy is the key to transform this material, from what I understand. So can you elaborate on that?
Thank you, Jackie. It's a good question. I think you probably have answered some of the questions that you just asked. Now, I personally retired in 2017. And when I retired, I did not foresee participating in the bamboo business. I was introduced to bamboo by my ex-colleague and my mentor. And I think the market is not short of sustainable green material. One of the key thing that interests me in bamboo is what you just described. What I have described is because it's not just a green material, but bamboo economy is a very important global social initiative, alleviating people the less privileged from poverty. I think the environmental and social kind of elements of the bamboo economy is what interests me, and that's why I decided to see whether we can create kind of a win-win-win situation where it can rebalance the environment and climate. It can alleviate the less privilege in China and Southeast Asia and the tropical regions, and also it can create kind of a business enterprise from it. Because what I think is, if it cannot be commercially be successful, it's not sustainable. I mean, it cannot sustain. So it has to kind of to create some business model from it. And after the last 2 or 3 years, and then collaboration with Andy, Dr. Fan, I think we are really seeing the possibility of and the potential of creating a viable business model from it. And science, I always believe, is being one of the key issues. New science discovery, new potential, new material, and can always lead to a new value proposition that we can bring forward to the market. And then we can create new market demand on bamboo as a material. So when Andy described the global bamboo market of what, 6 billion, maybe up to 8 billion, I see it would much more than that. Besides the global push for net carbon zero, I think the new value proposition that Andy and I, the group that we're going to bring to the market, will really help to push forward the bamboo business. I think it's just for the green is not enough reason. I think you need to bring something else to the people. I think one thing we mentioned in Super Bamboo is it cure one of the key problem in engineering bamboo, which is we use a lot of glue, which is harmful, which is, you know, anything you can think of. But now in Super Bamboo is a glueless material, and has a strength comparable to industrial steel. I think that the combination by itself can really open up a lot of opportunity for us going forward. I hope I've answered your question.
Yes. Thank you, Alex. I guess for us, when the architects, we specify bamboo, we know that we are doing more than just using the material and having it look good. We are actually contributing to a social economic cause.
Absolutely. I think architects are one of the most important group of stakeholders in the global bamboo movement. And I would hope that you guys going forward, when you are looking for a more natural and environment or ambience, when you try to use wood, you have to ask yourself a question first. So why not bamboo? Before you make your final decision on what kind of material you want to specify for a particular environment.
Absolutely. So my next question is for Dr. Dong. So the sustainable research on, you have showed us your sustainable research on circular economy. And in terms of bamboo, we all know that it's very sustainable because of its fast growing characteristic. And in Asia, you can even likely get elite credit for using local material. So when we talk about sustainability in terms of circular economy, how do you see bamboo and its end of life as a post-consumer product? Or are you thinking the material cycle in terms of a prolonged life? And Alex, also feel free to answer this question from a supplier and manufacturer point of view.
Okay, Jackie, I think that is a very great question, and actually it's a very big concern for the bamboo recycling. We know, in my slide, actually, I highlighted in my slides, actually, we consider scenarios like we want to burn the bamboo for power generation for 90%, but only 10% will go to the landfill. That is our scenario projection in my research. But as we know, in the real condition, actually, it's very difficult to, for example, for Hong Kong to recycle the bamboo and burn in the power plant for as high as 9%. So how we can explore in the future, I think maybe the two directions we can explore in the near future for the end of life bamboo, the application. For example, the first one will be bamboo, as I mentioned, in nature, it is the biomass. So we can use the bamboo as a biomass to produce the bioenergy. For example, the power generation is one way. And also the second way will be we can also to utilize the bamboo to produce the biofuels. That is some case in Singapore and Malaysia. So this is of course the good idea, because if we can use the bamboo to produce the bioenergy, that means we can reduce the fossil fuel consumption. So it's a very big contribution to the total carbon emission. So in the world, it's the first option. The second part will be the bamboo also as there's also some potential to apply the bamboo into some other use. For example, in Japan also use a lot of bamboo, and some part of the end of the life bamboo will be used for to produce other items. For example, the cup. In Japan, they produce the bamboo cup instead of the plastic the cup. We know in nature, the plastic comes from petroleum, and petroleum is also the high carbon content. So if we can reduce the consumption of the plastics into the cup, so we can also of course to generate the bigger contribution to reduce consumption on the petroleum to reduce CO2 emission. The point will be maybe also how we can drive the consumption market to see the value and, for example, the culture, the issue of bamboo product. For example, how we can motivate people to use the more bamboo, the handkerchief and the handcraft and the cup to substitute other materials. Also some big potential in the near future. And also then we come back to Hong Kong. So my case is actually the condition in the European Union. They burn the bamboo 90% and only 10% will go to landfill. I'm afraid current Hong Kong, maybe the data will be inverse. Hong Kong, I guess maybe only 10 to 20% will be power generation, but maybe most of the bamboo will be landfill. We know landfill actually will decompose the bamboo, so it will generate some other gases emission. For example, methane also the pollution and the greenhouse gas emission to climate change. So how we can reduce the landfill, the bamboo will be the bigger challenge for the amount projection in bamboo and to generate the future benefit on the carbon emission. So here actually I recommend the Hong Kong government can think about, and the first will be how we can utilize some market scheme to motivate the power plant to use bamboo as a biomass to produce the power generation, and also how we can think about to use more bamboo to produce biofuel, for example, for transportation and at least for the public truck and buses. And also Hong Kong can also think about how we can produce other items use bamboo, like the case in Japan, we use the bamboo to produce cup and the living items. I think here we call for the imagination and the inspiration from our designers and architecture to try to incorporate bamboo into the daily life. Is also a very important part. So anyhow, for the end of life, I think the biomass energy and also to use bamboo to produce the items will be the main two ways for maybe for Hong Kong and the world to utilize the bamboo in the end of life. It will generate both the benefit on the the whole life cycle carbon emission. Of course, we also need some shift on the culture, and we need some maybe the market scheme to motivate people to do so, and also we also need some the good design to use bamboo can also motivate more people be likely to use the products. Something I think I can think at this stage. So that's my point. Thank you so much.
Thank you, Dr. Dong. For me, bamboo going to landfill is definitely bad news. So we really need your help, scientists, to help us look at the end of life of bamboo, so we can really talk about circular economy in a real cycle. So my last question before opening up to the audience is my question for Dr. Rong and Andy, founder and co-founder of Super Bamboo. So for us as architects, most often we see bamboo as flooring materials, interior cladding material, and more often we use them for furniture, for fixed furniture. So in terms of Super Bamboo, what is the next step? I guess in your slide you posed that as a question, the next step, and I guess how do you see us as architects use Super Bamboo and apply Super Bamboo to buildings?
I think Andy can answer that question. Maybe because there's another question related to the fire retardant. Maybe I can answer that one.
Okay, sure. Yeah. So I think the question regarding whether bamboo and timber can actually overall become a building is, as Alex said, very much regulatory, and in the past we have been limited by the lack of building codes for using bamboo more into high rises, for example. But I think we can only hope, and we can predict that things are starting to change, because organizations like ISO are starting to release new, more focus on engineered bamboo material standards, and I think that will help us in a long way to integrate bamboo into buildings. And then in terms of the next step, if you want to explore more than just interior design for bamboo, I think we always have to start smaller. Maybe you can think about prefabricated, maybe modular single house constructed using bamboo, and see how those bamboo in load-bearing bamboo are behave, and then we can scale up starting from maybe single house to maybe multiple stories, and see how to gather more data. I think that's the important part. Gather more data and always show proof to the public in terms of publications, how engineered bamboo can really be just as good as wood and steel and concrete buildings. That's what I think.
Well, talking about Andy, thank you for bringing up the idea of using the bamboo as a structural material, which I think is also what Dr. Fan is trying to kind of leaning towards about, like, by doing the super bamboo, restructuring the cellular, you are improving the strength of the material. But and of course, like similarly for timber, like there has been a lot of successful cases in the past decade of using mass timber as a structural material in North America and also in Europe. And what we learned from that process is really the first step is about the local regulations, and in particular to fire retardants, how the material behave in the case of fire. So I mean, such a discussion in terms of legislation is still something that yet to be happening here in this part of the world, like in Asia or in Hong Kong specifically. So I guess my questions for Dr. Fan, one is, when we talk about timber, there is the charring rates. The fact that when you try to set a fire with the wood, I mean, it starts charging. So it's kind of stop the fire from spreading. Like with bamboo, does it have a similar physical properties that allows the material to like not spreading the fire, or do you rely on external chemicals to make it happen? Say for a traditional bamboo, and also for the bamboo, the super bamboo that you are investigating. So if you can share some of your thoughts on this.
Okay, thank you, Florence. Yeah, I think your question is also closely related to the question from the audience. That what product to make bamboo fire retardant? And also one of the audience give a question that if we want to be able to build larger building with a structured bamboo, the fire resistance rating and certifications will become very important aspects in specifying bamboo as a building materials. So from our product, especially because we know that wood is more popular compared to bamboo and wood as a construction materials because of they have a lot of standard. But actually in current stage, we don't have a very solid standard for bamboo structures. But compared to wood, we know that especially for the fire retardant, if a material inside can contain a lot of oxygen, or if it can contain some fires inside, can contain some air inside. The air can be used as the combustion accelerations. We know that, right? Because if you have airs, it will be more easy to fire. But for our super bamboo, because we already fully compressed it, which means the total materials will have no air inside. So which means naturally our super bamboo will can produce the more fire resistance compared to the nature bamboo. So that is the first topic, and that is the first stage that we are working on. And the second stage is that we will do the surface treatment to our super bamboo. We know that the wood can be used as the wood charcoals, but also bamboo, it also have the same transportations from chemical transitions from the bamboo to bamboo charcoals. But usually we will not let the bamboo to reach to charcoals. We will just slightly do heat treatment on the surface area to make it more fully densified. In that case, other than that, we'll have the surface coating on it. Then the total process will make our super bamboo can have a higher fire resistance compared to the existing product.
Thank you.
Thank you.
Thank you. So I guess we have answered the questions from the audience. And we have another question from Samuel. Where do we start from?
I think Samuel's question reference back to his interest in setting up factories in Africa.
I think it's totally feasible. As you can see, the manufacturing process for engineering bamboo is actually quite simple. At the same time, labor intensive. I think that should fit with the current economic situation in Africa from that perspective. And I know that Africa also have quite substantial forests, bamboo forest resources. So if you look at from that perspective, I think it's feasible. And if you look at it, say from the market perspective, if you are going to serve the, say, the European market, serving the European market from Africa certainly will save transportation costs and of course carbon footprint as a result, if you compare to exporting from China directly to Europe.
Thank you. I hope Samuel, this answers your question. So next we have, I don't know how much time do we have. Can we answer one more question?
Yeah, we still have time.
Okay, so we have a question from Rex. The trend in construction in Hong Kong these days is to attempt to shift the production from site to factory environment in the hope of executing projects more quickly and safely. In the context, what are the key advantages of using bamboo as a structural or finishing material?
I think there isn't any real added advantage, say, comparing bamboo with other building material. But what we can say is the current manufacturing capabilities in China are able to deliver MIC products in bamboo. So I think that would answer this question. And I cannot share more, but I can share with the group that we are currently working with government to look at potential prototype for MIC bamboo facilities for smaller facilities that could be used in Hong Kong. I think the driver behind is actually that the question that from the audience is how we could produce not just MIC but close to carbon neutral facilities for the society. And as we can see, if you look at the embodied carbon in among building material, bamboo is definitely one of the lowest. And if we can tackle a few regulatory problems, technical wise, it's already feasible that we can actually produce MIC or whatever DFMA facilities in bamboo in China, and then we can ship the whole thing all the way to Hong Kong, and then for very simple installation on site. And for instance, your question earlier about the fire properties. Now, currently, we need to have chemical additive to bamboo to achieve certain fire rating. But in Hong Kong, there's a particular requirement in terms of fire performance is the non-compostability, which is the BS 476.4, I believe. And I can tell you no carbonized material, including wood, can survive that test because the temperature is just too high. But my question is that absolute necessity that we have to satisfy before we can put bamboo in as a building envelope or in structural use? Because we have experience using structural bamboo in China, and also we have a different fire test that is required in China, which is ASTM standard, which is specifically for performance of structural element in fire situation. And the engineered bamboo that we produce can actually satisfy that fire test. Otherwise, you won't be seeing the slides I'm showing about the structural bamboo that we have done in China. So we have to satisfy those fire tests, although it's not the non-combustion in Hong Kong, but it can survive in a fire situation. I believe it's 420 minutes for 2 hours. So I think that is something that I would like to share with the audience is how flexible, how open the government is towards the question, do they just stick to the letter of the word, or do they really want to look into the rationale behind or the real meaning behind this regulation to see how they can come with all the new material or new inventions? I think that is what we need from the government.
That's a very good point. Yeah, it is to really not just stick to the text, but try to questions or go back to the original intention.
Exactly.
Of the regulations.
Yeah.
Yeah.
And I think we can always start from small and
Yeah.
bigger.
We're trying to start from small with the APDs. Hopefully, we can have something done next year. I don't know.
We look forward to see.
Yeah.
So another question from the audience is from Ken. So I think his question is about in the old buildings, in heritage building in China, we found wood and timber quite often. And how come we don't see so much of a bamboo building material in the heritage building in China?
I'm not sure I've answered to that question. I'm not as familiar in the heritage building in China. So I honestly, I don't know.
I think if I would like to offer my thoughts is that, again, in the past, we know that bamboo has been used for building materials for a long time. But if you talk about, long-lasting heritage buildings, then you need to have a material that can last and material that is feasible to build with. And bamboo, in its raw pole round-shaped cylindrical form, was just not feasible to do that. And that is why the recent development of engineered bamboo that turns this round-shaped bamboo into more of a rectangular shape that is standardized for buildings will unlock a lot of opportunities. And I think that is why we need to look at it in terms of this new phenomenon is in this technological development. That's my 2 cents. Yeah.
That's right. It was not too long ago that we see the round shape bamboo turn into a orthogonal shape,
Yeah.
kind of panels.
Mm-hmm.
There is, I see that Adrian has a question, but we are not seeing the exact question, a quiz from Adrian phone.
So I saw some audience raise a hand, so maybe we can invite him or her to ask some questions. I see one person raise a hand.
Yeah. Well, yeah, I've been allowing the audience to talk, but yeah, no. Well, I think there is one last slide that we need to share that try to conclude today's discussion, right?
Yeah. So shall I do that?
Yeah.
The closing remark, I think we have covered most of the items in this closing remark. I think the first thing is the global heat wave this summer, I believe is a very harsh reminder that we need to act now before it's too late to rebalance climate on Earth. And engineering bamboo being one of the most carbon negative building material, as Dr. Dong has demonstrated in his assessment, applying bamboo in buildings could create a very significant carbon sink, contributing to the environment rebalance. And as we said, I mean, we still have no answer to the recycled bamboo materials. A good question asked to that. But if we can apply bamboo as a building structure, I think we can prolong the life of bamboo as if it's being used as a structural component in the building. To just now we're using it's a filler material which doesn't really have the long life that we're hoping for to create the needed carbon sink for our climate. And we talk a lot about the science and research on the material. I think with the increased market demands, naturally it should channel more resources to the research and development of bamboo. Super example is a prime example in terms of scientific breakthrough in the building material. We honestly believe that the zero adhesive content and the exceptional strength of super bamboo can really open up a lot of opportunities for bamboo, not just the application scope that we are looking at right now, but way more than that. We are looking at possibility of bamboo replacing not just the other bamboo or wood, but possibly metallic or other artificial materials. Because when you look at the research result from Dr. Fan, super bamboo can achieve a very thin, very low thickness, and still maintaining a very high stiffness. So at that I think that will open up a lot of opportunity for us for other application as well. Now at the end is we mentioned that in different locations is we really need your support. I think architect support is instrumental to the global bamboo movement. So we would really want to call upon you guys to think about bamboo in your next design to join our journey to promote the bamboo economy. I think that's it from me.
Wow. Thank you, Alex. And also thank you, Dr. Dong, Dr. Fang, Andy, and Jackie for these wonderful discussions. I'm completely amazed by the level of investigations that your team has been moving into. And for those who are interested in investing your future in bamboo, if you want to talk to Andy or Alex, contact us and we'll get you connected. And also, I finally saw the comment from Adrian Fong, our audience. which I think is a very appropriate way of concluding our event today. He is saying that this old Chinese saying, you cannot eat a meatless meal. And so you cannot live in a place without bamboo. So with that, thank you for joining today's event, and hope you have a wonderful weekend. Thank you.
Thank you. Thank you, everybody.
Thank you.
Thank you,
very
everybody.
much.
Thank you.
Very much.
Next day.
Thank you.